Right, this video is for section 2.6 in your notes. We're going to combine a section in here that's not in your syllabus, and it's because this material that we're going to do in 2.7 we actually need for the next unit, for the next section. So linear inequalities is the title of this unit. And in general, an inequality is solved by the same process as a linear equation, the things we just got through doing. There's one exception, and it's crucial that you remember it every time. And the rule is that when you solve an inequality, and an inequality is going to have one of these symbols on it, anytime you solve or use an inequality, when you're in the solving process, if you multiply or divide on both sides of the equation with a negative number, then you must switch the inequality around. So if you solve the problem and originally it said less than, and you divide by a negative number, then you've got to flip your symbol around by the division of a negative. So the rest of the problem works just the same as we do when we solve a regular equation, and you just have to be careful about what your symbol's going to say. Now, when we solve inequalities, basically we're not limiting ourselves to one answer. We're limiting to a range of answers that could satisfy and be true. And many of you, as you're going to be working into in a field environment, most of the time when you're working and you're reading gauges and you're looking at things that are levels of stuff, you're not looking for something that's an exact, you're looking for something that's in a range between two things. Has to be greater than this or less than this, or in between these two numbers would be acceptable. So that's the application part of solving inequalities. We're looking for, just kind of needs to be in this ballpark type answer. But the process of solving is going to be just like a regular equation. So here we have 5x minus 4 less than or equal to 16. Because the smaller end, in order for it to be true, the smaller end would always be pointing to the smaller number. So here I have to solve, so I'm going to add the 4 to get it over on the other side with the numbers. Then I have 5x less than or equal to 20. And then I'm going to divide by 5. So I have x less than or equal to 4. So what this is telling me that any number that's below 4, that could be negatives, it could be 0 or 1 or 2 or 3 or any fraction that's in between, as long as it's less than or equal to the number 4, then that would be an acceptable answer. Now, we're going to talk a little bit later about how we would graph those answers, because some of your homework problems is going to be asking you to graph your solution. Okay, number 2, here we have a problem that has a fraction in it. All right, so I want to there's no adds or subtracts, so I need to get rid of that fraction first. So what I'm going to do is I'm going to multiply on both sides by the denominator that I have. So I'm going to multiply by 3. And then when I do that, on the left, the 3's are going to cancel, and I'll just be left with negative 2x. My symbol here is just a less than. It doesn't have a bar under it, so it's not an equal to. And here I have negative 6 times 3 would be negative 18. Now this time I am dividing by a negative, so I have to go up here and remember what I mean, what this tells me to do here. Since I divided by a negative number, that means this symbol has to flip around, so this is going to become a greater than symbol. Okay, so I'm going to put a circle around it, and that means we have to flip it over because we divided by a negative. So now I have x, negative 18 divided by negative 2. Be careful with your signs. The signs are the same, so my answer is going to turn out to be positive. Now, this time, it says your answer choices that you get have to be greater than 9. It cannot be 9, but it could be that tiny little fraction that's just on the other side of 9, like 9.1, 9.5. Anything on the right-hand side of 9 on the number line would satisfy this equation. Okay, over here, I'm going to have to move some things 2 directions, because I'm going to have to get my variables on one side and my numbers on the other. Now, in this case, when we're working with inequalities, and because we read from left to right, it's much easier to keep your variables so that your variables are going to be on the left-hand side, because then you read exactly left to right and it makes a whole lot more sense. So here, if I subtract 7x so that my x's end up on the left, I'll have negative 3x. And if I move the x's come this way, then my numbers are going to go that way. So I'm going to add 4 and add 4. Then I have negative 3x is greater than 6. And now I'm going to divide by negative 3. And again, I'm dividing by a negative number. So that means my symbol here has to flip around. So it's going to be a less than now. And I have x less than negative 2. Now, if you move your variables the other way, okay, so I'm going to work this one again. 4x minus 4 greater than 7x plus 2. Okay, if I move the 4x, and so I move my 4x over here, I'm going to subtract it. Then my 3x is going to end up over here, but it's going to be positive. Okay, if my x's are on the right, then my 2 has to come over. And I'm going to move the numbers to the left, and I'll have negative 6 over here. Now, when I divide by 3, I'm still going to get negative 2, but notice my symbol doesn't flip this time because I didn't divide by a negative on the 3. My symbol's still going to point that way, but my x is on the right-hand side. So basically what I have to do is I have to think about this as if it were in a mirror, and I have to flip it around the other way. So if I took this one and I flipped it over, then it would mirror itself. So the x would be on the left like this one. The small end would be pointing to x, which here it points to x, and then I would have negative 2. So the thing that you have to do is if your x ends up on the right-hand side, you basically have to read it backwards, okay? So the symbol, when you change and rewrite it, read it backwards, okay? So go backwards with it, and it will say x less than, because the small end is pointing to the x, negative 2. Now, the way to avoid that is always make sure your variables end up on the left-hand side. This is the, you don't have to, but that avoids some problems that you might run into. All right, so this problem gets a little more complicated. That just means we're going to distribute this 4. Be careful with your signs. So I have 5x minus 10 plus 4x plus 28 less than 0. Now, everything is on the left-hand side, so I'm going to just combine like terms and have 9x, and negative 10 plus 28 would be positive 18 less than 0. Well, now I have to get the 18 moved to the other side. Okay, get variables on one side, numbers on another. So I'm going to subtract 18, and I get 9x less than negative 18. I'm going to divide both sides by positive 9, so nothing's going to change, and I end up with x less than negative 2. So this would be your final answer. And when they ask for it to be written in notation form, this is what your answer would be looking like. Now, if they ask you to graph it, we're going to do that in just a minute. Okay, here we got 2 fraction problems because I know that there's a test coming later, and I know that it has fractions on it. So we do need to continue to practice those. Okay, I'm going to look at my fractions, and my 2 denominators are 3 and 2. So I need something that both of those numbers will go into. The smallest number would be just multiply them together, and that would be 6. So I'm going to multiply both sides by 6. Now when I multiply the whole numbers, they just become like 2 whole numbers. So 6 times 2 would be 12x. Now when I multiply here, I'm going to reduce the denominator into this multiplier. So 3 goes into 6 2 times. Multiply what's left over times the 2 on top. So 3 goes into 6 2 times the 2 on top would be plus 4. Over here, take your denominator and multiply it and cancel it out. So 2 goes into 6 3 times. 3 times 3, so this would be greater than 9x. 6 times 1 would be minus 6. Now move my variables so they're on the left. Subtract 9x. So now I get 3x. I'm going to move the 4 over there, so I'm going to subtract 4. So I get greater than negative 10. Then when I divide by 3, I'm not dividing by a negative, so my symbol doesn't change. I get x greater than negative 10 thirds. Now, on your homework, it's going to say leave it as an integer or a reduced fraction, because 3 will not divide evenly into 10, and so they're not going to accept that as an answer. Do not use a calculator on this kind of problem. If it doesn't divide evenly, then it's not going to be an acceptable answer. If you divide it and it just gives you a whole bunch of decimal numbers, then your answer's wrong. You need to go back and leave it in an improper fraction form, just like this. All right, number 6. Okay, we've done this kind of problem before. It was in one of the other examples. If I look at my denominators here, I have a 7 and a 10. So the smallest number they'll both go into would be 7 times 10 would just be 70. All right, so I'm going to put brackets since I've already got parentheses. And I'm going to multiply by 70 on both sides. That 70 is going to do good for me because it's going to help cancel out each denominator. Now the first 70 goes times the whole number 7. So I'm just multiplying those. That would be 490. Now when I go to the second one, 7 goes into 70 10 times. 10 times 1 would be minus 10. Then just bring down the parentheses. You don't multiply the denominator out here times the parentheses. You only multiply it times the whole numbers by themselves or fractions. And then over here, 10 goes into 70 7 times. 7 would be left over times the 7 here, so I have greater than or equal to 49. Then put your parentheses, 3x plus 1. You don't multiply times the fraction and times the parentheses. Now distribute the 10 and distribute the 49. So you have 490 minus 10x plus 30 greater than or equal to 147x plus 49. Okay, combine any like terms that you can. Let's see, 490 plus 30 would be 520 minus 10x greater than or equal to 147x plus 49. Okay, use your calculator. You're going to subtract the 147 so that it ends up on the left, because then we read from left to right. So I'm going to subtract that. So I'm going to end up with negative 157x greater than or equal to, I'm going to move the 520, so I'm going to subtract 520 over here. Pull out your calculator, and you got 520 minus 49. So I don't have my calculator handy right here. 520 minus 49. 1, 11, 4. So 471. Then we're going to divide, and we're going to divide by a negative this time. So divide by a negative, and check and see if that divides evenly, and then you'll have x greater than or equal to negative, oh, let's flip the symbol, sorry. And I didn't get me a calculator in here. So then you would just divide that out and see if it comes out even. I don't believe it comes out even. So for the time being, we're just going to call it negative 147 over 471 over 157. You probably won't get many with that kind of an answer on it, but you've got your calculator to check it and see. So 8 and 4, 12, and then that probably is pretty close to the right answer. All right, over here, we're just going to use our decimals, and you've got a calculator, so you can just plug things into the calculator and multiply. So 0.04 times 1, so that would be 0.4x, minus 0.4 times 4 would be 1.6, and then less than or equal to 0.6x minus 1.6. Now, when you try to put things together, I'm going to subtract the 0.6 minus 0.6x. So I'm going to end up with negative 0.2x. When I add over here, what's going to happen? Notice that makes it cancel on both sides. But when we add opposite numbers, they always should add up to 0. So it's going to be less than or equal to 0. Then when you divide, it's going to be divided by a negative 0.2. And over here, you're dividing by a negative 0.2. So the negative rule is in effect here. So when you divide, that means you got to flip your symbol. So x has to be greater than or equal to 0 divided by anything is still going to be 0. It doesn't change the number, but it does cause that sign to flip. Okay? Now, the problems here on the bottom is from a section in our that we formerly used to cover, and it's talking about compound inequalities. A compound inequality is kind of like in English a compound sentence, when you put two things together and you use the word and or you use the word or in it. Well, this is the same thing that we do here. If a problem is written so that it's two problems, and sometimes they're two totally separate problems, and they're joined together with the word or, we have a name for that. It's called a disjunction. Okay? Now, all you're going to do is kind of draw your little squiggle line where the or is, and then you're going to work each part. So I need to move my 3x over here. So I'm going to subtract 3x. That'll be a negative x. Then I'm going to move the 5 to the right. So I'm going to subtract the 5. So those are gone. And I have less than negative 6. Now, that negative is really a negative 1 in front of that x. So I need to divide through by negative 1. That's going to flip my sign. Going to flip my symbol, so it becomes x greater than, and dividing by negative 1 is going to make that become positive 6. So if you need to, divide by negative 1, but dividing by negative only changes the signs. Okay, on this side you're going to just work out that problem the same way. I'm going to bring over the negative 2x, so I end up with negative x again. Then I'm going to add 4. So I have negative x greater than 10. I'm going to divide through by that negative, which means all I'm going to do is flip my symbol around and change my sign. So it becomes x less than negative 10. So I have two possibilities for my answers here. A disjunction says either one, the left-hand problem has to be correct, or the right-hand problem has to be correct. And so if you choose a number that's greater than 6, then that will be an acceptable answer, because you're only trying to please one person. So if you ask somebody and say, which candy bar would you like to have, Milky Way or Snickers? And if it's an or problem, and that means that either one will be acceptable. So it doesn't matter which section you choose from, because it's or, either answer is acceptable. So we have two different answers here. But our answer in what you would write would be or in between here. That is, the word or is part of your answer. So then if we would solve each part of the problem, and then we have two possibilities, because you just have to satisfy one of them. Now, if we go to an and problem is a little bit different, because an and problem wants both pieces to be satisfied. So this is called a conjunction. Now, and problem means we got to satisfy both of them. So we have to look, and at our answer, when we get down to the very end, we got the word and in between. So I'm going to subtract 1, and then I have 4x greater than or equal to 24. I'm going to divide by 4, and I have x greater than or equal to 6. And over here, and I'm going to subtract 4, and I have x less than or equal to negative 11. So, positive 11, sorry, positive 11. So now, if I think about this in terms of what these numbers are telling me, I'd have to look at it on a number line and think about what it's looking for. If I have all my numbers that are 6 to 11, I want both of these to be satisfied at the same time. So I want all the numbers greater than 6, so I'm going to go here and go this way. And I want all the numbers that are less than or equal to 11, so I'm going to start here and go this way. So I'm looking for only the numbers that are in between where both lines overlap each other, because that's the only place where both equations would be true. And that is called an AND problem. So our answer here says that our x values have to be less than or equal to 11 and greater than or equal to 6. So when we write an AND problem, we're going to put the x in the middle, the two numbers on the end, the bigger number on the right, the smaller number on the left, but our symbols are all facing the same way. Because if I read the left-hand symbol, it says x less than or equal to 11. If I read this one and read it backwards, the big N points to x, so x would be greater than or equal to 6, and it would satisfy this picture that we have right here on the graph. Now, part of your problems are going to involve doing some graphing, and you're going to use the little graphing scale thing on your MyMathLab software. So you're going to have to just do some practice with it to make it work right. If the number is an equal, if there's an equal underneath underneath your symbols here, it would have a hole on it. Okay, so these would have a hole on the graph, and these would have a solid on the graph. So that's important that you make sure you pick the right symbol when you're graphing. So in this problem it says I want all the x's that are greater than negative 2. So if I think about it, this would be 0, and somewhere down here would be negative 2. So if I'm going to graph a picture of what those numbers would be, it's greater than, so it's not going to be equal, so it has to have a hole. So at negative 2, I'm going to put a hole on the graph. But then I want all the answers that are going to the right, and so then my graph would be shaded this direction. Now, if you write your problem so that your variable is on the left, that little arrow is telling you exactly what it should look like on the graph. So here, I want to find the number 9/4. Well, divide that on your calculator and see what it's going to be, because on a graph it would make more sense to have it probably in a decimal form, or find a place where you could locate it. Now, if I just divide it out with a number, how many times does 4 go into 9? 2 times, with 1 left over, because that would be 8. 9 minus 8 would be 1. So it's about 2.25 on the graph. So on my number line, if I have 1, let's see, 1, 2, 3 on my number line, where am I going to find 2.25? Well, it's not quite 2.5, it's not quite half, but would be somewhere about right here, and it does say equal, so I'm going to put a solid dot on this one. And now it wants the arrows pointing to the left, so everything that I'm going to shade would go this way, so I'm going to darken in that part of the graph going that way. So I need a solid dot because it has an equal, and I need an arrow to the left because my arrow is pointing to the left. Now on this one this is like an AND problem right here. Okay, the answers have to fall in between these two numbers. So I'm going to just put my two numbers on the graph where they would go, because I need the positives on the right and the negatives on the left. And then I'm going to put my symbols. This one doesn't have an equal, so this number would have to have a hole on it. And the 4 does have an equal, so this one would have a solid dot on it. And I want all the values that fall in between those two numbers, then there would be my answer that looks like this. Now, if it's an OR problem, I just have two separate graphs, because most of the time on an OR problem, they're just two different pieces on the number line. So here, I'd plot me a -1, I'd plot me a whole number 2, and then I'd do each one separately. So this one says I want all the smaller numbers, the numbers to the left of -1, and it would have a hole, and I'd shade this way, put an arrow there. And then on this end, did it get dark all of a sudden? I think it just went off. There we go. And then we go to the right hand side, and this does have an equal, so I'm going to make a solid dot here, but this one says point your arrow and go to the right, so all my numbers are going to go to the right. Okay? Now we'll go to this one, and it says and. So this time we're going to be looking for the place on the graph where both are satisfied, where both cross. Okay, so this one I'm going to locate -3, and I'm going to locate +2. So now I want to see, I want to go greater, so I'm going to go to the right of -3, so it's going to go that way. And then I'm going to go to the left of +2, and it's going to have a solid dot, and I'm going to go this way. So I look for the place and where they overlap. So my answer would be graphed right here in between these two. Now, usually an OR inequality graph will be a number line with arrows pointing opposite directions. Oops, here we go. Okay, and an AND inequality will be the overlap where the two individual graphs would overlap. Okay, it's called the intersection. So only the overlapping portion would be the area where there's a solution to it. Now, okay, when you get to your college algebra portion of this course, you're going to be asked not to do things so much on a graph, but you're going to ask to be doing them in what's called interval notation. So it's basically taking the picture and just writing the information down of what the picture looks like. Now, if it has a solid dot is going to be replaced with a bracket. Okay? A solid dot will be replaced with a bracket. And an open circle will be replaced with a parentheses. Okay, and it's 1. It'll either be 1 on the left or 1 on the right. It only uses one of them depending on which way you go. And then your solution would be continuing on maybe one direction or the other, and you would use an infinity symbol. So if the answers go on forever and ever in one direction, you would use a symbol, and either it would be in the positive direction or the negative. So if we go back here and look at number 1, if we look at the graph on number 1, the graph is starting at the number -2 and going as far to the right as it could possibly go. But the -2 has a hole on it. So instead of putting a hole, I'm going to put a parentheses. I'm not going to write a number line. I'm just going to write what the numbers are. So this would then be -2. So that says there's a hole at -2. And then it's going to continue going everywhere to the possible to the right. So you just put a comma and you show what the other end, so way out on the other end of this number line would be somewhere around positive infinity. So this always has to have a parentheses. Because we don't know where that ends, where infinity ends, we would just have a parentheses there. Okay, so let's look at number 2. Number 2 up here, the left hand end is going all the way forever to the left. So this time you always write left to right on here. So the left hand end of this number line is going to infinity, so it would be negative infinity because it's going in the negative direction. And then it's moving and coming to the right, and as you come to the right, it approaches the number 2.25. And so I would put a comma, and I would put a 2.25. And because it's got a solid dot on it, I would close this with a bracket. So we don't have to have a number line when we write interval notation. Sometimes you have to picture it in your head, but when you get to college algebra part of this in a few weeks, this is what you're going to be expected to do. And so I figured it's easy enough. We can go ahead and talk about it now, and then when Ms. Swatoya is working with you, it won't be totally something that you've never seen before. Algebra in high school does this the same thing too. All right, so number 3. Let's look at number 3. We want all our numbers to fall between two numbers. So this time, the two numbers, we don't have an infinity on either end. We have numbers on each end. So my numbers are going to be -2, 4. And then the -2 has a hole on it. So I'm going to put parentheses where the -2 is. And on this end, there's a whole number 4 with a solid dot, so I'm going to bracket it, and there's your interval notation. So we don't have to draw a number line. Now on number 4, there's two separate graphs, so you have to write two separate interval notations on it. So you just do the left one. So the left one here is going to -infinity, so I'm going to -infinity on the left. And it comes up and it stops at -1, but it has a hole. So -1 with a parentheses. And then I have my other one on the right hand side. It starts at 2 and it's got a bracket right there. It's solid. And then it goes on to +infinity, and you don't have to put a plus sign, and it has to have a parentheses. But the most important thing that you have to put in is you have to put a U right here, which says we're going to unite and join these two together. So you have to put both of them separately, but you put a U in between to show that you need both of those as part of your answer. Okay, so it's the whole thing like this. And then on this last one looks kind of like 5 and number 3 are kind of the same problem. So we just look, it started at -3 and it had a hole, so -3 with the parentheses, and it goes up to +2 with a solid dot, and then I bracket off that one. So solid gets a bracket, a hole gets a parentheses, infinities get parentheses. Okay, so here's kind of a challenge one. All right, if we put this on the graph, let's see what it would look like. So I want everything less than -3. So let me see, I'm going to be at -3, and I want a dot that's solid because it says equal, and I'm going to go this way for that one. Okay, then I'm going to go from 0 to 4. 0 to 4. And at the 0, I want a solid dot. At the 4, I want an open hole, and I want everything in between on those, because my X is in between those two numbers. And then on the right hand end, at 6, I want a circle because it doesn't say equal, and I want to go everything to the right. So now, interval notation is going to be 3 different pieces. So here, I have -infinity, and it's going to come in to the right and stop at -3, and it's going to have a bracket because it's got a solid dot. Then I'm going to join it to the middle piece, which starts at 0 with a bracket and goes up to 4 with a parentheses. Then I go to the far right and I'm going to join it again. It's going to start at 6 and it's going to go to +infinity and stop right there. So this is a concept that you're going to have. I probably will give you some practice problems and also give you maybe on a test, ask that you show me an answer in interval notation. This is just part of a learning process that will help you down the road to not have to have so much stuff coming at you at one time, and it's an easy concept to learn. So I hope this has helped you, and I hope you get a chance to watch this video.